Good day everyone, I am Artric Jeano Morilla and we will be having a tutorial about differential equations and its applications. Just enjoy. Thank you.
Good morning everyone. Now we will be having a tutorial about differential equations and its applications. First question. Show that f of x and y equals k is a general solution of the differential equation mxy dx plus nxy dy equals 0 if and only if m beta f over beta y minus n beta f over beta x equals 0 holds identically. First, let us assume that the values of m and n are beta f over beta x and beta f over beta y respectively. For this condition to be satisfied, to prove it, we substitute the assumed value of m and n in the condition equation. Here, m or beta f over beta x multiplied by beta f over beta y is just equal to beta f over beta y multiplied by beta f over beta x. So, subtracting same values will result to 0. So 0 is equal to 0. Next, substitute the values of m and n to the differential equation mxy dx plus nxy dy equals 0. Here, by substituting, we can get beta f over beta x dx plus beta f over beta y dy equals 0. And we can get df equals to df of x and y equals to 0. By integrating both sides, we can get f of x and y equals to 0. And this is just a solution of the differential equation. Take note, just a solution. So the general solution the general solution of the differential equation is f of x and y equals k, and where k is any arbitrary constant. Our second question is y double prime plus y prime squared plus 1 equals 0. Solution. Let y double prime be equal to dy prime over dx. It will result to dy prime over dx plus dy over dx squared plus 1 is equal to 0. And dy over dx squared, dy over d plus dy over dx squared plus 1 is equal to 0. So manipulate it, transpose it from the other side, dy over dx squared is equal to negative dy over dx squared minus 1. So dy is just equal to negative dy squared minus dx squared over dx squared multiplied with dx squared. It will result to dy is equal to negative dy squared minus dx squared. Next, integrating every term, we can get uh, integration of dy is equal to negative integration of dy squared minus integration of dx squared. We can get integration of dy is equal to negative integration of y dy minus integration of x dx. From this, we can get y is equal to negative y squared over 2 minus x squared over 2 plus c over 2. So, since 2 is a common denominator, so we multiply both sides by 2 to get the denominator here and to transpose it to the other side. So this will result to 2y is equal to negative y squared minus x squared plus c. So the answer or the function or the solution is y squared plus 2y plus x squared equals to c, or c is equal to y squared plus 2y plus x squared. The next problem is 2x plus y multiplied by y prime is equal to 1. Solution. Let y prime be equal to dy over dx. Then, by substituting the value of y prime, we can get 2x plus y multiplied by dy over dx is equal to 1. Then 2x plus y dy is equal to dx by transposing the denominator of the denominator dx to the opposite side. So we can get 2x plus y is equal to dx over dy. And manipulating the equation, we can get y is equal to dx over dy minus 2x. Or it can be in the form dx over dy minus 2x is equal to y. Here, we can observe that it is a linear differential equation derived with respect to y. So, derivative of the function x in terms of y. So, we should find the integrating factor. V is equal to e raised to the power of integral of negative 2 dy, which is equal to e raised to the power of negative 2y. Multiply the right hand side, or which is y, with the integrating factor, we can get y e raised to the power of negative 2y. Here we by the procedure of how to solve linear differential equation, we multiply x, which is the dependent variable, with e raised to the power of negative 2y. We then both integrate both sides, and we can get x e raised to the power of negative 2y is just equal to the integral of 1/4 u e raised to the power of u du. By integrating by parts, we can get that x e raised to the power of negative 2y is just equal to 1/4 of negative 2y e raised to the negative 2y minus e raised to negative 2y plus c. By dividing both sides by e raised to negative 2y, we can get that x is just equal to negative y over 2 minus 1 plus c e raised to the power of negative 2y divided by 4. So we can get that x is just equal to negative 2y minus 4 plus c e raised to the power of 2y divided by 4. Next problem is y is equal to xy prime plus 1 over 1 plus y prime. Solution. Let y prime be equal to dy over dx. Then we can get y is equal to x multiplied to dy over dx plus 1 over 1 plus dy over dx. Manipulating the algebraic equation, we can get that x multiplied dy to dy over dx plus dx over dx plus dy. Manipulating it further to the right hand side, we can get y is equal to quantity of x dy multiplied to the quantity of dx plus dy plus dx squared divided by quantity of dx multiplied by dx plus dy. Distributing the variables, we can get that y is equal to x dy dx plus x plus 1 dx squared divided by dx squared plus dx dy. So multiplying dx squared plus dx dy to both sides, we can get y multiplied by the quantity of dx squared plus dx dy is equal to x dy dx plus x plus 1 dx squared. Then by separating the variables or the common variables, we can get that y minus x minus 1 dx squared is equal to x minus y dy dx. We integrate both sides, integrate y minus x minus 1 dx squared is equal to the integral of x minus y dy dx. So the integral of, then we can get the integral of yx minus x squared over 2 minus x dx is equal to the integral of xy minus y squared over 2 dx. So from this, we can get yx squared over 2 minus x cubed over 6 minus x squared over 2 plus c is just equal to yx squared over 2 minus xy squared over 2. So yx squared over 2 is common in both sides, so we can cancel it. So the result will be c is equal to x cubed plus 3x squared minus 3xy squared divided by 6. Our last problem is about an application of differential equation. The question is, when a switch is closed in a circuit containing a resistance R, an inductance L, and a battery which supplies a constant voltage E, the current I builds up at a rate defined by the equation L di over dt plus Ri is equal to E. Determine I if I naught is equal to 0 and if the battery is replaced by a generator which applies an alternating voltage E naught cosine omega t. Solution. The equation L di over dt plus Ri, because E t is multiplied by 1 over L in order for it to become standard linear differential equation. So with integrating factor e raised to the power of integral of r over L dt, this is equal to e raised to the power of t r over L. Multiplying the integrating factor to the right hand side will result to e over L e raised to the power of TRL dt, with the derivative of I multiplied by e raised to the power of TRL. So integrating both sides, we can get I e raised to the power of TRL is equal to E over R, or the voltage over R, multiplied to E raised to the power of TRL plus C. So we can get from that equation that IT is equal to voltage over R plus C E times E raised to the power of negative TR over L. And if I naught is equal to 0 at T equals to 0, I 0 is equal to 0. This is equal to E over R plus C E raised to the power of negative 0 R over L, which is equal to C is equal to negative voltage over R. Then the current build up, or IT, is equal to voltage over resistance minus voltage over resistance multiplied with e raised to the power of negative tr over L. And when I naught equals to 0 and e is equal to e naught cosine omega t, I of t will be equal to the original equation, I over it is equal to e over r minus e over r multiplied with e raised to the power of negative t r over L will become it is equal to e naught cosine omega t over r minus e naught cosine omega t over r multiplied to e raised to negative t r over L.